morning. Here I am with a solution for the tasks that have been included in the written part of the examination on the last day of January, so the recent one. So the first task, we have a pair of metallic balls that are placed in vacuum at a distance of 2 meters. They are carrying charges of opposite sign and the same magnitude q. The radii of two balls are equal to 10 millimeters. That is, they are negligible when compared to the distance of the balls. Electrostatic force attracting the balls is 1 micronewton. And we should find out first the charge. So we have two balls. And they carry charge, let's say q and minus q. And in this case, the attractive force is given by the law of Coulomb and is F equal to Q1, Q2, the two charges, so Q1, Q2, divided by 4 pi epsilon r squared, where r is the distance between those two balls, epsilon is the permittivity, in this case of free space, and pi is a known constant. Now, in order to find out q, and given that q1 and q2 have the same magnitudes, we can change this equation into q is equivalent to a square root of the force times 4 pi epsilon r squared. Well, and this gives a value which is 21.1 nanocoulomb. So that's the first reply. The second question is, where is the maximum of the electric field strength? Now, where does the strength come from? It's a result of two charges that superpose in linear media. The vacuum is linear. And they superpose, so there is a special direction in which both charges produce the same orientation of the field, and that is the x. Here in between those two charges, this positive charge gives out this direction of field strength, and this negative charge adds another vector which combined produce the total field strength. And now the maximum point must be first at this point of this ball and this point of the other ball. There are 2 points at which the field would reach its maximum. So that's the second reply. And now there was a third question. The field strength in the middle of the structure, that is between the balls. So now we have to find out the field strength just in the middle, here. This point is in the distance of 1 meter from the center of this ball and as well 1 meter from the other one. And the resulting field would be a superposition of two electric field strengths. Each of them is caused by one of the charges. As the charges are of the same magnitude, as the charges are in this point creating field of the same direction, and as the distance at that point is equal for both charges, those partial field strengths would be equal. And therefore we can, for example, take it in this way. The total field strength E would be a sum of the field caused by the first charge and the field caused by the second charge. And those are equal, so we can take 2 times the first one. So that, again, according to a known equation, would be 2. Now the equation for electric field strength caused by a point charge 4 pi epsilon r squared. Now we have the r is just 1 meter, so squared again 1 meter. We divide 2q by 4 pi epsilon, where epsilon is the free space permittivity, 8.855 multiplied by 10 raised to minus 12 farad per meter. And this produces our result, which would be around 379 volts per meter. Just to be on the safe side, the unit for field strength is volt per meter, not Newton per Coulomb. And that completes the solution of the first task.